obviously, and so then now we have a ratio scale that we could, for example, put into an AHP type of analysis. So obviously this is slow and cumbersome, and you wouldn't want to just off the bat say we're going to do this for everything. But I think it's a useful complement to a sort of standard AHP analysis for either when you've got some comparisons that the people really haven't thought about, and you want to make sure they think about them sensibly, or they volunteer that they're stuck and want some help making those decisions, making those weightings.
Is there a risk, I forget, is it reference bias, or, you know, when you're doing, how much would you pay for a house, for instance, you know, those kind of researches, and if you give them a number to start with, that will influence the end result as well. So depending on how you go about it, I can see that kind of being a risk as well. If you start with, I don't know, 0.6 and
Right.
frame a reference and then influence the outcome as well.
Right, yeah, so if you started at the bottom versus starting at,
Yeah.
at the top.
I think you can have different ways.
Yeah, and yeah, that's true, and I'm not sure what the right way to deal with that is. I mean, I guess, well, probably the best way to deal with that is rather than presenting them in sequence, to just sort of present kind of have a randomized order in which these get presented. So that, and have them, you know, not just four that you can sort of keep tracking in your head and be actively rational about it once you've picked a transition, but have it sort of popping back and forth and lots of different values, and each time you have to make a decision. And there'll be a region in the middle where you're kind of inconsistent, and that's the indifference region. Another approach, completely different, is to work simply with ranks, right? So we've got 5 criteria. Ask each person to rank them. What's most important? What's second most important? What's third most important? People are often more comfortable doing that than trying to put scores on them. And so then, if we have a bunch of ranks, how can we turn those into criteria weights, right? Obviously, we want the top rank to be higher weighted than all the other ranks and so forth. And so there are a couple of techniques. So if we're ranked, if we have the ranking so that one is most preferred. So we have RJ is the ranking of criterion J. So then the rank sum method says calculate the weight of criterion J according to N is the total number of criteria, subtract the rank, right? Because we want a small rank to be associated with a large weight. Add 1 to, that's just what they do it. And then normalize it by summing over this value of all the, for all the criteria. Okay, so this will give you a weight between 0 and 1 that will be highest for the first ranked, next highest for the second ranked, and so forth. Now you could say, well, why did we pick this formula? Well, in fact, you can come up with other formulas that preserve the rank order but give different, you know, but give slightly different distribution of weights. Another one is called rank reciprocal. And here it's just the rank of alternative or criterion J is just, for so again, this, when rank is small, the weight's going to be high, which is what we want. And so, if you, and there are some other formulas that are out there. They all give slightly different answers, but actually, if you look at the results of doing these two, obviously you get the rank order of the weights stays the same, but even the numeric values aren't that different. So this has the benefit in that it's easy to compute, it's easy to explain that you're just taking the ranks. So it's easy to elicit the information, it's easy to compute, and it's kind of transparent. You apply this formula and people see their ranks turned into weights that make sense. There's not really any theoretical foundation for it. And if there was information about sort of the relative weights between adjacent ranks, that's lost. But people who use this say it seems to work pretty well. I don't know if anybody's kind of done rigorous comparisons of this to the more quantitative approaches like AHP. And then the last approach that's often used it's called rating, so rating method. And the typical way to do it is to say, here's your 5 criteria, take 100 points and distribute them across those 5 criteria. Okay, so you might give 40 points to criterion 1 and 30 points to criterion 2 and 10 and 10 and whatever's left. Okay, and then those can be translated directly into weights just by dividing by 100.
Group project style?
Group project style. So yeah, so you've done this. So are you still? Is this still how they're doing group project selection?
Yeah, really. 20 points?
100.
100 points?
100 points. So there's how does that work as a way of eliciting preferences?
Well, we have to choose 3,
Mm-hmm.
and there's a maximum of 80 points that you can allocate to one. And then it goes into your algorithm to
Right.
maximize the utility for the sum of all the points for all the students.
Right. So in that case, there's probably the risk that because in that sense you're not really weighting criteria, you're going straight to the alternatives. And so there's probably a bit of game playing that goes on.
Oh, there's, yeah.
And so it's not necessarily an honest signal of your preferences. If you were forced to give some points to all, or if it wasn't because you're in this game with 100 other people, it might turn out differently. But the idea is the same. That this is how it's done. The other place I've personally seen it done, when they were planning marine protected areas along the coast of California, they did interviews with fishermen to try and find out what areas were particularly valuable for fishermen. And the spatial resolution of the fisheries data was not that high. And so they would go to fishermen, so a team of social scientists would visit individual fishermen, sit down with them, talk about where they fish, and the fishermen would sort of draw general areas on the map that they like to fish in. And then they were given 100 pennies and said, distribute these pennies among these different regions that you've drawn according to how important they are. And then these importance scores for each sort of spatial unit were then summed up across fishermen and across fisheries to give kind of a fishery importance And again, it's not, it was, I was working with a group project that was dealing with this, and one of the questions that came up was, well, what does importance mean? It's not, it could mean that's where they get their most profits. It could mean that's where they spend their most time. It could mean that's where the most fish are. It could be that's where the fishing is easiest, right? I mean, every fisherman probably has something different in mind when they say importance.
Well, in that example, you're ranking the alternatives, not the weights, right? You're going straight to the alternatives.
Yes. So it's not, at that point there weren't alternatives on the table. It was more a way of scoring place.
But
places in space.
you're scoring the
Yeah.
actual
Yeah.
alternatives instead of saying allocate points to, how pleasant it is to fish there versus
Right.
how good your catch is versus how expensive it is to fish there. Those would be the sort of criteria, right?
Yeah. Well, and there was, and they chose not to ask those kind of explicit criteria. I think on the basis of both past experience and sort of social science research on how people think about these kind of things. But one could easily ask the same kind of questions about how important is, how important is sustainable seafood versus how important is economic prosperity. And it actually is, because of the way it was framed, it really is more of it was a values question. How much do you value this patch of the ocean versus this patch of the ocean?
How you deal with when you know that a group of stakeholders use lag, like is the case, I don't know here with the fishermen, but almost everywhere else, you know that when a fisherman say that he's going to fish there or there is, this place is really good, he's usually lying. How you deal with that?
GPS tracking.
Yeah, but in these small fisheries, you can actually not do that. And to create the GPS is super easy.
Yeah, so I think that is an issue, and that's the other problem with the fishery data is that the fishermen when they come in their catch is measured and they have to fill out a form saying where they fished. And first of all, the spatial resolution of the reporting is very poor, and in many cases they lied. And it said they were fishing somewhere other than where they were. And I think that's why. First there was a long period of gaining the fishermen's trust, because this whole process unfolded for so many years. Initially, the fishermen didn't want to provide any information at all. But once they saw that the planners really were trying to put MPAs in places to avoid where the fishermen wanted to fish, they became more and more cooperative. And then the other is by, first of all, by having this kind of vague notion of importance rather than saying where do you make your most money or where do you catch the most fish. It's the information is a bit more vague. And then it was also, they were very careful to keep it all anonymous. So the only thing that the decision makers saw was the map of total importance value summed across all fishermen and all fisheries. Okay, so there was no, the people who ran this process were able to convince the fishermen that, the specific information about where you, Joe Smith, fishes will not be available to anybody. Which is mostly the reason they lie, is because they don't want their competitors to find their good fishing spots. But it is an issue. You have to think about it and find creative ways to deal with it. There's no simple answer.
Obviously, the big difference between both of these rank systems and the point allocation system is that the point allocation system allows for indifference, where these do not. Does that end up playing itself out in important ways that change the results in the end?
Well, I suppose if you were truly indifferent, then you would rank the two equally.
Is that allowed, though?
Sure, you can say,
get more information with the allocation method type of grading. Because the size of the difference matters.
Yeah, yeah, no, yeah, I mean, any of these, the allocation or these sort of pairwise comparisons, you get more information because you get actually the strengths of the preferences rather than just the rank. Last thing let's see, yeah. So, did everybody get a chance to read through this Steele et al. Paper? So, the first part of it, hopefully, was kind of a review, sort of a summary of mostly of AHP and value theory approaches. Was there anything in that review that struck you or seemed at all confusing? Yeah.
I mean, I just didn't really understand why the scale and the weights have to be so connected.
Okay, and so that's actually the central part of the
Yeah.
central point of the paper. And we so first of all, I mean, we talked in the first lab about the importance of the scale, but just to in case those of you who don't have it with you, if you look at table 2. So this is just a simple example where we have two things that were two criteria for some project, ecosystem functioning and cost, and we say, well, we think each of those are equally important. But the scale, one of them is measured on dollars and one of them is measured on a 0 to 1 scale, right? And so the result of this is that when you compare them, that the difference in cost, because its absolute magnitude is so large, really dominates the difference in ecosystem function. Okay, so it really doesn't matter what the ecosystem function scale is; it's all going to be driven by cost because of the scale of cost, and because we're weighting them equally. The more complex example about and this is still really about scaling. We've got this is now a wind energy project, and we have two criteria we're interested in: reducing CO2 emissions and bird mortality. Okay, and the solution to the previous problem, right? This problem is just to make sure that put everything on a 0 to 1 scale, right? Then it's comparable. But how do you scale that? And we talked about this in lab, right? You can scale it from you can scale it for the range of the data, right? Which we talked about, or there's some sort of a priori scales that you could use, right? You could say that score 0 is an intolerable level, right? So no reduction of CO2 emissions and 5,000 birds killed, right? Those are sort of intolerable level. And then the best possible one would be best possible scenario, which would be complete reduction of CO2 and no birds killed. And when you use that first scaling, you get that the option 1, there's two options under consideration. Option 1 comes out being slightly higher score than option 2. In contrast, you could set different less extreme values for 0 and endpoints for 0 and 1, and that gives us option 2 coming out ahead. Okay, so and we saw that we saw this a little bit in lab. But this is a more sort of extreme example where how you scale the values onto a 0, 1 Now, why does this matter with the weights, right? We could fix this problem by changing the weights. Right, I mean, there's, if on this extreme scale, we really do have equal weights, when we move to this moderate scale, then we could, all we have to do is adjust, so then equal weights don't really fit that new moderate scale, because the range, the relative range of variability may have changed for the two, well, in fact, it has changed for the two criteria. So, the weights only make sense in the context of a knowledge of what 0 and 1 represent. Right? Because you're saying, basically the weights say, how much do I prefer a 1 in the CO2 scale over a 1 in the Hertz scale? And the problem is that in common practice, that's not how weights are elicited. You start off with the values and say, okay, what's your preference for birds over CO2? Right, in a kind of abstract and vague and general way. And then this decision is often made on a rather, is often made not by the, by the analyst who's sort of helping behind the scenes, and often made for an arbitrary basis. So this is the point of this paper is, after having had our discussion in the first week, it should be pretty obvious that you can trade off weights and scores. And the problem is that in common practice, that's often not recognized. So, I don't know.
I understand why you need to adjust the weights, but I think it's that only happens if your level, your 0 and 1 are poorly defined. Because if you decide that in a proper way, you shouldn't be changing. You don't need to change the weight. The weight is supposed to be with what is your preference, and your preference shouldn't change if the scale that you're talking is not changing.
Right.
So, I really.
If the scale changes, your preferences could change.
Yeah.
If the scale is between 0 and 1 bird versus 0 or 100 parts per million
But
CO2, it's going to be different than 0 and 1,000 birds.
It's hard to put it on a balance what is the meaning of 10 ton of CO2 or 10, 10,000 birds. So your weight is not going to, your weighting is not going to capture that. How you capture that from your stakeholder. So that is why you should choose your scales really well, and then, stay with that and go by the way.
This is really interesting because the assumption in a model like this is that the obvious example they're giving is that the scores have to be, an increment of score has to be comparable across the different scores you're using. But that doesn't necessarily say that they're linear. What it really says is that they all have the same distribution. So as long as the scores are distributed between bad and what you would call a bad score and what you would call a good score the same way for each one of the things that you're scoring, the linear combination should still work properly. But I would imagine that since these scores tend to be assigned somewhat arbitrarily, you wind up with situations, well, I know in situations that I've seen, is you're trying to assign these nice, neat linear scores to some things that are distributed non-linearly, some things that are kind of basically force all of these things to fit in these round holes,
Right.
so that you can then, and you try and treat the assignment of preferences as orthogonal. I prefer birds to oil slicks, regardless of how you measure birds or regardless of how you measure oil slicks. But yeah, the scoring things. I mean, we've spending a lot of time in here on assigning the weights, which is huge. But this, the how you set the scores up in the first place is a really big deal.
Yeah. Yeah, and that's true, and in these examples, it's we assume that the scores can be easily coerced with this linear framework. We talked maybe it was in the lab session where you were with us. We talked a bit about nonlinear scoring systems and trying nonlinear value. But I think that if you think back to the AHP example from last week, we started by eliciting weights without regard to score. We just said, I prefer style. Style is twice as important as fuel economy. And that is a common way that AHP is, or AHP, and MCDA in general is performed. You start with the values, right? And these values are framed in kind of big picture, vague ways, and you run into this problem. So I think, in practice, that the solution to getting a set of weights that really is consistent is you have to elicit those weights with respect to a particular range of otherwise you just get nonsense.
Can you define the scores based on the weights? I mean, if you we ran through the process of the AHP and we define the weights, and then based on these weights, define the scores for each.
The scores are supposed to be objective, external to the weights that people give them.
Yeah.
That's
That's the principle. It's supposed to be separable.
Yeah, I was thinking in the limits, the 0 and 1, but
might be able
that
to.
doesn't make sense.
Bruce, do you know of any work that's been done on seeing if people come up with if some of these supposedly metric independent techniques like AHP actually come up with different answers if people are referencing them back to different scales?
I don't know if work that's been done, but again, it's kind of a framing problem. How you prime someone's brain to think about style versus fuel economy. So
Maybe, I mean, if you, and in particular, if the precision that you get from the scoring system that you use is, say, smaller than the precision which you're used to thinking about the problem, so it forces you to make some lumping decisions up front, and then you elicit your weights based on that. You might be getting, you might get different weights from people saying you've got values going from 0 to 3 versus values 0 to 10. I have no idea. I was wondering if you knew of any people. It seems like the obvious follow-on to this is to see.
yeah.
Do people, are there, in fact, would a process like AHP, which is supposed to be independent, would it actually tease out different weights from people? The only difference being that they have different scoring metrics to work with.
Yeah. I mean, and I guess in thinking about that, the other way to do this, aside, instead of saying you have to have the scores in mind when you do the weighting, is you can ask people to do the weighting, and then when we're assigning scores, you actually elicit from the decision makers, well, what's good in this criteria? What's a good level of CO2? What's a bad level of CO2? Because that presumably references back to what they were thinking when they did that prioritization. The challenge there is that then every decision maker is going to give you a different set of scales. But
That sounds like a process that is not guaranteed to convert.
right. So so we're out of time for today. So on Thursday, there's just one more bit of stuff I want to do in lecture, and then the rest of Thursday will be devoted to time for you to work on the assignment. And just have all of you looked at the assignment? Those of you who are actually in the class. Okay, so we can discuss any questions about